Today we have a 2014 RAM ProMaster with a 3.0 liter, and the check engine light remains on the dash while the engine is running. So this vehicle is losing power tremendously. And the customer also stated that the throttle body light comes on the dash when the vehicle is being driven down the road. So the first thing we're gonna do is we're gonna confirm the complaint. After confirming the customer's complaint, we're gonna connect a scan tool to the vehicle to see what kind of trouble codes we have in the engine computer. So now let's confirm the customer's complaint. So right there, as you can hear, the engine is running and the check engine light remained on the dash. So right there, check engine light is on. So customer's complaint confirmed. Okay, our check engine light indeed remains on the dash. I'm gonna turn off the engine. I'm gonna turn the key back on. And after that, I'm gonna get the scan tool connected to the vehicle. After I get the scan tool connected to the vehicle, I'll bring you guys back up so we can scan the engine computer. And as you can see, the scan tool has identified the vehicle. So we're gonna click OK. We have two trouble codes in the engine computer, and these two trouble codes are causing the check engine light to remain on the dash. The first trouble code is P0402-00, and it says EGR flow excessive detected. And then the second trouble code is P0101-00, and it says mass airflow sensor A circuit performance. And then we have one code in the transmission control unit. Our code is U0415-00, and it says implausible data received from ABS. So it looks like the ABS control unit is not talking to the transmission control unit, or it's not sending the right data to the transmission control unit. We're gonna focus on these two trouble codes, but before we do that, I wanna scroll down and see what else we have in the other control unit. Let's see if we have any other trouble codes in the other control unit. We got 0 codes in these control units, so that's good. We have the same codes on the generic side of the tool, so that's good. Okay, and we have a glow plug code over here. So now we're gonna go back to the OE side of the tool. So we're gonna go into the engine computer. Let's talk about this really quickly before I tell you what directions we're gonna go so we can fix this. So let's look at the codes once again. So when I see EGR codes and mass airflow sensor code set in the engine computer, I usually like to go after the mass airflow sensor trouble code first, and I'm going to tell you why. Let me tell you a little bit about the EGR system. If you have a question about what the EGR is or what EGR means exhaust gas recirculation. We have EGR systems in vehicles to reduce the formation of NOx. Okay, NOx is not a good gas. NOx causes a lot of problems, so to reduce it, we have installed EGR systems on engines to reduce the temperature of the cylinders, okay, to cool down the cylinders a little bit. Now, how does it work? To cool down the cylinders, the manufacturers reuse the exhaust gases and they send the exhaust gases back in the engine to cool the cylinders. So it's basically recycled exhaust gases that go through a cooler, and then they go past the EGR valve that opens and closes, and it goes into the intake manifold and then eventually in the cylinders. And this usually happens around deceleration. When the computer decides to cool down the temperatures in the cylinders, it opens the EGR valve to allow exhaust gases to go back in the engine to cool the temperature of the cylinders. When the computer opens the EGR valve, it looks at a couple inputs to verify if the EGR valve had opened. I mean, all systems are not the same. Some of them have a couple inputs that the computer looks at to know if the EGR valve actually opened. Some of them have a temperature sensor after the EGR valve. The computer also looks at the mass airflow sensor input when the EGR valve opens. And on the EGR valve assembly, there is a position sensor that tells the computer the position of the valve when the valve opens. Okay, now I believe on this model, the computer looks at the input coming from the mass airflow sensor. So basically what happens when the EGR opens, we allow recycled gases to enter the engine. When these recycled exhaust gases enter the engine, the amount of fresh air that's entering the engine goes down because we are diluting the mixture inside the cylinders. So instead of filling the cylinder with fresh air, we're now only going to fill the cylinder with halfway of fresh air, and then the other half is going to be exhaust gases coming through the EGR. So when this happens, the input of the mass airflow sensor should drop. So there will be a change in the signal of the mass airflow sensor. The computer looks at that change to know if the EGR valve opens. Now, I've seen instances where a mass airflow sensor would go bad and send a skewed signal to the engine computer. And when the computer sees this skewed signal, it's not going to know if the EGR valve opened or not. Okay, and then it's going to set these two trouble codes, because we could have a EGR system that's working fine, but if our mass airflow sensor is sending the wrong info to the engine computer, the computer is not going to know, especially if the mass airflow sensor is the only input that the engine computer relies on to know if the EGR valve opened. Now what I'm going to do is, because it's one of the two, we either have a EGR valve that's sticking, because the EGR excessive flow trouble code can be caused by a sticking valve, a valve that's either sticking open or not closing all the way, or we could have a defective mass airflow sensor. Either we have a bad EGR that's sticking open, or we have a bad mass airflow sensor. Or we could have a leak also in the inlet tube between the mass airflow sensor and the throttle body. That can cause these trouble codes to be set sometimes. So now what I'm going to do is I'm going to click on this diagnose button. Let's see if we have a TSB about this trouble code before we continue. As you can see, we don't have any TSBs about this code, so that's good. So I want to go to our real fixes. Let's see what we got here. We don't have any information available about this trouble code. So let's focus on this EGR code first. I'm going to go into my service info. Let's read up a little bit about this trouble code. I want to read the code setting criteria. I believe it's kind of going to be what I said, because these EGR systems are pretty similar. Okay, so let's go to OEM testing. So we're going to read the theory of operation. The EGR airflow control valve is a pulse width modulated output controlled by the powertrain control module, PCM. The EGR flow control valve is used to control the ratio of fresh air flow to the EGR gas airflow. The PCM monitors this ratio with the mass airflow sensor. The mass airflow sensor feedback is very prominent in determining the position of the EGR flow control valve. If the mass airflow sensor feedback does not match what the computer is expecting to see when the EGR airflow is requested, it can affect the operation of the EGR valve and the EGR airflow control valve. This can occur if the mass airflow sensor feedback is faulty or inaccurate. Even if no DTCs are actively set, the EGR system and diesel particulate filter regeneration is disabled when the fault is active. So when you have an EGR code set, your diesel particulate filter is not going to be regenerated by the engine computer. Okay, the regeneration will be disabled if you have this fault. We have just read that the mass airflow sensor feedback is very important in determining if the EGR system is working well. Okay, we're going to check the mass airflow sensor first. Let's see. When monitored with the engine running, ambient temperature above 19.4 degrees Fahrenheit. Okay. The powertrain control module detects EGR flow is more than the requested flow for 10 seconds. So this is if the flow is excessive for more than 10 seconds, this trouble code is set. Okay. So we could have a bad mass airflow sensor or an EGR valve that's sticking open. And the customer told me that the throttle light is flashing sometimes. So with this code being set in the engine computer, this is what's causing the throttle light to flash sometimes, because the regeneration is not being initiated. And the possible causes are air filter, intake system air leaks or restrictions, EGR airflow control valve, EGR cooler and tubes restricted EGR valve. Okay, so it could be the EGR valve itself. We could have a leak between the mass airflow sensor and the throttle body. We could have a defective mass airflow sensor. So that's good to know. Let's see what else we have. Oh, look here. Note, if there are any mass airflow sensor DTCs, diagnose the mass airflow sensor DTCs before continuing EGR diagnostics. Okay. So it comes back to what I said earlier. We have to make sure our mass airflow sensor is working, because we can have a defective mass airflow sensor sending a skewed signal to the computer, and the computer in return is going to set a mass airflow sensor code and the EGR flow code. Okay, so we can read this flow chart over here to see how we're going to go about diagnosing this, but I'm not going to read all of this. So let's back out. And let's go into the engine computer, and I want to look at my data. I want to look at, hopefully we have some EGR data PIDs and mass airflow sensor data PIDs. So let's go to engine. I'm going to graph this. Airflow measured, and then airflow target. Okay. I believe these are the only PIDs that I need to diagnose this. So now I'm gonna start the engine. Let's take this for a test drive and see what happens. As you can see, the check engine light is still on. So our airflow measured is actually slightly different from our target airflow. So this is basically the desired, and this is the actual. Okay, so on the desired we have 422, and the actual is it's bouncing between 320 and 316. Okay, so our actual is lower than our desired. Okay, and our EGR valve is not open right now. Okay, let's drive with our code in the engine computer first, and then if we don't see any changes, I can go ahead and erase the trouble code and see what happens. So our EGR, I see some movement over here. So I'm gonna put the scan tool down here. Let's go for a test drive and see how this thing drives. So I'm watching the scan tool also as I drive, and I'll tell you what I see on the scan tool. We are driving. I'm also looking at the scan tool at the same time. So right there, our throttle light is now flashing. You see the throttle light flashing right there? So the throttle light is flashing. So once again, we have confirmed the complaint that the customer is complaining about. Okay, now I'm gonna stop here really quickly. Let's look at the scan tool. So here's what we got. I'm gonna pause this. So the airflow rate, our target airflow rate went up to about 1300 milligram per stroke, but our actual didn't go as high. Okay, it didn't even go past 1000. Okay, so it looks like we have a mass airflow sensor that's under reporting. Our EGR duty cycle over here was 138%. EGR functionality on airflow sensor refer to electrical and plausibility faults. So no, so we don't have a circuit fault on the mass airflow sensor circuit, so no wiring issue. That's good. Okay, and then the airflow rate signal period was 401. I don't know if this one is millisecond. EGR control looped, disabled, EGR fault. This is interesting, guys. So I'm going to unfreeze this. Now what I want to do is I want to back out and I want to erase these trouble codes. Let's erase these trouble codes. I'm going to turn the engine off. I'm going to turn the key back on. Let's clear these codes and see which code comes back first. I'm going to clear the codes. I'm going to read the code again. As you can see, no codes present, so that's good. We know what codes we're dealing with, so no big deal if we lose our trouble codes. I am going to select the same data PIDs again, and then we're going to drive to see which code comes back. And then after that, I have an idea about how we're going to fix this. When we get back, I want to check this mass airflow sensor first, because it looks like this mass airflow sensor is under reporting. And then this vehicle only has 107,000 miles. Okay, so I don't think we have an EGR valve that's sticking. I mean, at this mileage, I don't think so. We could just have a dirty mass airflow sensor. Okay, I mean, it could be. I mean, we could have a bad EGR valve too. You never know, but let's do all the tests we can to figure out what's causing this. All right, so that's it. Okay, I'm gonna start the engine. So this EGR valve is kind of changing status from like open to closed. See how it's going to, it was going from closed to open, closed to open. I don't know if that's normal. Okay, now one thing I've noticed is our measured airflow is now matching the target. Remember, just a couple minutes ago, this measured was way off from the target, but now it's matching it. Okay, so they're basically showing the same value, so which is good now. If we have a EGR valve that's sticking, okay, it's gonna affect the way the mass airflow sensor is working. Remember before, over here it was saying open. Okay, the status was saying open. I don't know if you saw that, but right now, okay, it says EGR in closing position, which is normal because the EGR valve is closed at idle. And then our EGR valve duty cycle is way less than what we had. I think we had 130% before, and now we have 10, 15. So that's good. So this tells me that our EGR valve right now is closed. Okay, but based on the numbers that we had, it's like our EGR valve was kind of stuck open a little bit. Okay, I'm gonna graph this, the command. Okay, the command of the EGR, this over here is gonna tell us if the computer is opening the valve or not. All right, so on the command, on the valve duty cycle command, we have less than 20%. Okay, it's going between 10 and 14%, but we have less than 20% at idle. Okay, and these two are mirroring each other at idle. So let's drive, and then we're gonna come back at idle to see if these numbers will still look the same. Okay, so I'm gonna put the scan tool here again, and then let's drive this. So check engine light is off because we erased the trouble code. All right, so I'm gonna bring up our scan tool. I'm gonna pause this. I'm parked on the side of the road. So over here is when the EGR valve opened fully. Okay, so kind of around this area. So it opened and then closed, opened, closed. So, you know, it's a pulse width modulated valve. Now over here it opened. As you can see, when the EGR valve opens up here, our input, okay, the signal of the mass airflow sensor drops. okay, because we have diluted air entering the engine. Okay, we have the exhaust gases entering the engine. Right over here, when the EGR valve closes, you see we have a rise, okay, in mass airflow sensor, because now we are able to suck in fresh air. And then when the EGR valve opens again, this drops. Okay, so far I don't see anything that looks off. Okay, because when the EGR opens, the signal on the mass airflow sensor should drop, which we are seeing right now. You know what, I'm gonna keep driving. I'm gonna keep an eye on the scan tool. If I see anything off, I'm gonna capture it and then I'll show it to you. Okay, so I'm gonna let this roll. I'm gonna drive and then I'll bring you guys back up if I see anything out of the ordinary. The van drives well. We're not losing any power. As I'm driving, the check engine light came back on and the throttle light started flashing. Okay, so as you can see, our fault code has reappeared and now the van is losing power. Okay, as you can see, I can't go over 40 miles an hour. Okay, we are now losing power now. Now we are in limp mode. Okay. So now the max speed I'm going is 40 miles an hour. So I'm gonna stop here. Let's stop here and look at the scan tool. Okay, so this is good because it's acting up now. Okay, so check engine light came back, throttle light is flashing. Okay, so let's bring up the scan tool. Okay, so now our EGR is stuck at 138%, which is not right. This number should be low. So this EGR over here is stuck. Okay, this over here is stuck and we now have a discrepancy between the airflow measured milligrams per stroke and the airflow rate target milligram per stroke. So right now our measured is showing 760 grams per stroke, and then our target, so the target is lower than the measured. Why is the target lower than the measured? Well, the target can be lower than the measured if we have an EGR valve that's sticking open, or we can also have, no, actually, no, let me think about this. No, I think I misspoke. We can have a mass airflow sensor that's sending a skewed signal to the engine computer, because this over here looks stuck. So I let off. So when I rev it, they both go high. When I let off, this number here comes down, but this one stays up. Why? Is it an EGR valve that's sticking open, or is it a mass airflow sensor? If the EGR valve is sticking open, this engine wouldn't be idling right now. This engine wouldn't be idling this way, because when it's a EGR valve sticks open, it's going to affect the idle. This engine would be dying. This engine idles well. Okay, so I'm gonna lean towards testing this mass airflow sensor, because I believe what's happening here is the mass airflow sensor is sending a skewed signal to the engine computer, and the engine computer is basically increasing this command based on the input it's receiving from the mass airflow sensor. Since we have a high command here, that means our EGR valve is stuck open, okay? Or it's kind of, because 138% means the valve is open. Okay, it's opened halfway, and if you have a valve opened halfway, it's gonna send exhaust gases in the intake. And when you have an EGR valve that opens at the wrong time, if your EGR valve opens at idle, it's going to cause the engine to not even run. The idle is gonna be sluggish, the engine is gonna die. One thing we can do is, let's back out. Let's read the code. Let's see which code came back. We got a lean code, we have an EGR flow code, and a mass airflow sensor code. Okay, now we have a lean code. Okay, so right there we have a system 2 lean code, a EGR flow code, and then a mass airflow sensor code. Now here's what I'm gonna do. I'm gonna turn off the engine. I'm gonna turn the key on. Okay, I'm gonna erase these codes again, and then we're gonna go to our functional test. Let's open the EGR. Let's see if we have an EGR test here. I'm gonna open the EGR at idle. You'll see when I open the EGR, our idle is gonna get rough. Alright guys, you know what? With my Zeus, with my snap-on scan tool, I don't have a bidirectional test that allows me to open the EGR. Let's go back to the shop and use our RTL tool. Hopefully with the RTL tool, we're gonna be able to open the EGR valve. So what I'm gonna do is we're gonna go to the shop. I'm going to open the EGR valve at idle to see if our engine speed is going to change. I'm gonna open the EGR valve at idle. If our engine speed changes, that will tell me that our EGR is working. The motor is definitely opening and closing. I mean, the valve is opening and closing, and we are diluting the mixture in the cylinder, because when you dilute the mixture at idle, the engine runs sluggishly. If it does, that should pretty much tell us that the EGR valve is most likely good. We don't have a clogged passage. Then I'm gonna focus towards the mass airflow sensor. We're gonna check the mass airflow sensor wiring. We're gonna look around the inlet tube to see if we have any leaks. Now let's drive back to the shop. Okay, so we shouldn't have any codes right now. So let's drive back to the shop. I'm gonna drive back to the shop, and when I get back to the shop, I'll bring you guys back up. And as you can see, our check engine light came back on and our throttle light is blinking already. Okay, this vehicle is losing power tremendously. I said that I was gonna use my RTL tool to open the EGR valve to see if our engine RPM is going to change at idle when we open the valve. After opening the valve, if the engine RPM doesn't change, that can be an indication of a defective valve or a clogged passage in the EGR system. Now, one thing I just thought about, I thought I would mention it, is a partially clogged DPF. Okay, I want to do a forced DPF regeneration first before we try to open up this EGR, because we can have a DPF that's partially clogged that can cause excessive back pressure in the exhaust system, which can cause the vehicle to lose power. It's something that we can try to see. I mean, your question might be, then why isn't it doing its regeneration by itself? But I did see a glow plug code. Having glow plug codes can sometimes disable the regeneration, okay, the active regeneration that the computer does by itself. So now what I'm gonna do, we're gonna leave the van outside the shop. Let's do a forced regen first and see if this is gonna get better. I'm gonna do a forced regen and then we're gonna drive it again to see what happens. So let's back out. Let's go to functional test. This is weird. We cannot do a forced regen with this scan tool. Diesel particulate filter lamp. I don't need that. Okay. So it looks like this scan tool cannot do a forced regen. So it's time to bring out the RTL. I'm gonna bring out the RTL and then I'll bring you guys back up. Let's see if our RTL can do the forced regen on this one. I got the RTL tool connected to the vehicle. We have the same trouble codes. Now we're gonna go into the engine computer. I'm going to erase the trouble codes first. We have the same ones, so let's erase these codes. So let's go to active test. So these are the only tests we can do. Let's go to special functions. We cannot do a regen with this thing. So in our active test, we don't even have the EGR test. This is frustrating, and we can't even do the regeneration. All right, I'm gonna do some poking around, and then I'll bring you guys back up. Let me see if I have a scan tool here that can do a regen, that can do a forced regen with this vehicle. Okay. So I'm gonna do some poking around, and then I'll bring you guys back up so we can decide about our next step.